Hey everyone, Dr. J here. This is going to be the amino acid chromatography lab. So before we get into it, a quick introduction. So as usual, I'm going to point out what's most important. So you are going to want to review the three functions of protein that we talked about. Structure, not only the muscles, hair, nails, skin, and ligaments and tendons, important to athletes. Structure. Number two, helps to form a lot of important chemicals in our body. Enzymes, neurotransmitters, hormones, antibodies, hemoglobin, forms chemicals. And number three, last resort for energy. Then you're going to want to review how many total amino acids do we have. You already know, 20. Of those 20, how many are essential versus non-essential? 9 essential, 11 non-essential. Make sure you review what the definition is of essential versus non-essential. I'm not even going to say it because you already know it. Let's review briefly the amino acid structure. Now, you aren't going to have to draw it, which is a good thing, right? But what I wanted to remind you of, most of the amino acid structure is the same. From here down, same. 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 What is it that makes an amino acid different? The side chain. So you're not going to have to draw these, but all we're reviewing is that the side chain is what's different. The rest is all the same, but this part is what makes each amino acid different. Today we're going to be working with our branched chain amino acids. Valine, isoleucine, and leucine. So what makes these different from each other is the side chain. You might be wondering, what makes it a branched chain amino acid? In simplistic terms, it's pretty simple. Other amino acids that are not branched chain have a more linear side chain. But these are branched chains. So what do you notice about these side chains? They're not linear. They branch. That's it. All right. So today we're testing the three branched chain amino acids, leucine, isoleucine, and valine. You're going to remind yourself of those three, which is closest in structure to our skeletal muscle. Let me hear you say it. Leucine. So remember, leucine is really important for athletes because it is most important to the structure of our muscles. In the introduction, in the actual write-up, 2 reasons why these are so important. Branched chain amino acids digest a little bit faster than the other amino acids. So one reason why these branched chain amino acids are good for athletes, they can be digested a little bit faster. Not as fast as carbohydrates, but compared to other amino acids, a little bit faster. Second reason, these branched chain amino acids, leucine, isoleucine, and valine, they are used for muscle protein synthesis. Sounds fancy. Muscle protein synthesis is building muscle. So why are these 3 so important? Because our body uses them to build muscle. Remember, not all amino acids build muscle. Some amino acids are used for the other functions. But these branched chain amino acids, they're digested faster and they can be used to build muscle. The recommended ratio is 2 to 1 to 1. 2 to 1 to 1. 2 parts leucine, if I can spell that right, to 1 part isoleucine and 1 part valine. This is what you need to review. Okay, really quick intro before we get to the actual procedure. Today we're using chromatography. We're being simple, right? The easiest definition of chromatography is it's a separation technique. We don't have to get all fancy. Separation technique. What are two examples in sports nutrition? Think about a sports drink company. Gatorade, they want to make sure that what they have on the label is actually what's in it. So they can use in their quality control department chromatography to separate the liquid, the water, from what's in Gatorade, sugar, electrolytes like potassium and sodium. So one application would be a sports drink. These companies, if they want to test their drink to make sure it contains what it says it contains, chromatography. Energy drinks, they contain a lot of stuff. So we can use chromatography to separate and see if it contains the components it says it does. Second example for how it's beneficial in sports nutrition. Testing for performance-enhancing drugs. Let's say a blood test. Let's say you're a really high-level athlete. Well, they're going to blood test you because they want to make sure that you're clean. This is a primary way that they use to test blood, or urine, but test blood for steroids and things like that. Let me go to an example here. Come on over. You have access to this, folks. Here's a real example of what a chromatography result would look like. Here we see the blood sample, and this is what our results are going to look like today. This is our unknown blood. And then we have two knowns. Here we've got a known if we're testing for growth hormone, and a known if we're testing for steroids. And what we're going to see is dots at different levels. The steroids dot is lower. The growth hormone dot is higher. So if you have your knowns, then we just take our unknown and we compare it. Does the unknown have a dot at the same level as growth hormone? Positive. Does the blood sample have a dot at the same level of steroids? Yes. So this blood sample is positive for steroids and growth hormone. So our results are going to look like that. All right, folks, our next video is going to be the actual experiment.